So we saw earlier that one method to find the inverse function when it existed was doing the opposite operations in the opposite order. This, however, really only works well for simple equations. So another method that's more versatile is to take and interchange your x and y and then solve the new equation, which is x as a function of y for y. So let's demonstrate this with an example. Here we've got we want to find f inverse when our y equal f of x is defined by square root 2x plus 1, but only for x greater than equal negative 1/2. So let's first double check and make sure this is a function. Let's do the horizontal line test here. So here I pulled up Desmos real quick. You could do your graphing calculator if you want to. So I'm going to graph y equals, and then I want a square root. And then 2x plus 1. Okay, so there is our square root 2x plus 1, and negative 1/2, x greater than negative 1/2 is going to be to the right of this point. So that's meaning that we only want the top half of that curve and not the bottom half. So by horizontal line test, this is indeed 1-to-1. You can see the horizontal grid lines, they only hit this graph at one point. So that's 1-to-1. So it does have an inverse. So let's interchange x and y. So we interchange here. X will be equal to square root 2y plus 1. And now we will solve for y. So this is step 1 and then step 2. So let's see, we're going to undo a square root by squaring on both sides. So x squared is going to be square root 2y plus 1, quantity squared. And so x squared is going to equal, the square and the square root cancel each other out. They're opposite operations. So 2y plus 1. Subtract 1 on both sides. So x squared minus 1 will equal 2y. And then divide both sides by 2. And these guys cancel. So we are left with y equals x squared minus 1 over 2. Or if you want, that's the same as if we put a 1/2 out in front. 1/2 times x squared minus 1. Or if you multiply the 1/2 through, it's 1/2 x squared minus 1/2, right? So it's an x squared curve, vertical multiplier by 1/2, and then shift it down half a unit. So if we go back to Desmos here real quick, we can graph that function. So for a second one here, let's do y equals 1/2 x squared minus 1/2. Minus 1/2. There we go. So the blue is the inverse function, and we want to restrict that and say just for x values greater than 0, because this part over here doesn't have a corresponding portion of the inverse. That'd be the negative down here, or a corresponding function of the original function. So this is going to be for x greater than or equal to 0. And notice here that our domain, x greater than or equal to 0, that was our range of the original function, right? The red function, the range, the y values that are hit is y greater than or equal to 0. So here you've got your function and its inverse, and they are reflections over that y equal x line. Right there's our y equal x line. So we restrict our domain on the blue one. That's the reflection of the red one over the green line. So that's pretty cool. Now in function notation, we would write f inverse of x is equal to 1/2 x squared minus 1/2. Now it's really more correct to use y's here as the input for f inverse, but we're just used to writing everything as a function of x, so we'll use this. And again, with restricted domain.